Okay, we are now recording. I'm recording this so I can put this on YouTube. So, like I said, on today, we're just going to focus on magnetic forces. I'm just going to have a very short lecture. We're going to review a few things, and I'm going to let you guys go. Okay, so up until this point, we've already talked about different types of charges that exist in nature. So I'm going to share my screen here. We all know that in nature, we have different types of charges. We have positive charges and negative charges, right? So the positive charges are what are called protons, and the negative charges are what are called electrons. Okay, and of course, if we have a material that has more negative charges and positive charges, um, or better yet, I should say, if we have a material that has more electrons than it does protons, that overall material is negatively charged. If we have a material that has more protons than electrons, then that overall material is positively charged. And guys, you all know the basic rule that opposite charges attract and like charges repel. Okay, so guys, it's very important that you guys understand that a similar thing happens with magnets. So in nature, just like we have positive charges and negative charges, it turns out in nature we have magnets which have north poles and south poles. Okay? So all magnets have a north pole and a south pole. And again, magnets are something that you guys are very familiar with. So these topics today, a lot of these topics should be something that you guys should already be aware of. So imagine for a second that I have a simple bar magnet that looks something like this. So this bar magnet is divided up into two poles. There's a north pole and a south pole. And so, guys, it should be obvious to you all that if I take another magnet and I bring this magnet close to this end, assuming that other magnet's north pole is pointed toward this end, then the north pole and the north pole will repel each other. But if I bring a south pole to this end over here, that south pole will be attracted to this north pole. So, guys, just like with electrical particles, in which opposites attract and like charges repel, a similar thing happens with magnets. So, like ends repel, opposite ends attract. So, in that sense, magnetic charges are very similar to electric charges. Now, here's an important difference that I want people to understand. Okay, guys, it turns out in nature, it is possible to have monopoles for electrical charges. In other words, you can have protons separated from electrons. However, that is not true for magnets. It is not possible to have monopoles for magnets in nature. What do I mean by that? Well, guys, let me explain this real quick. Most students have this misconception that if I take this magnet here and I break it, so if I take this magnet and I break it, like so I snap the magnet in two, so I break it along the middle here. Most students have this misconception that by me breaking this magnet, one end is going to be north and the other end is going to be a south pole. So one end is going to be a north pole, one is going to be a south pole. Most students have that misconception. However, guys, that is not true. It is not possible to break a magnet and produce a north pole and a south pole. There's no such thing as monopoles in nature. In fact, believe it or not, if I took this magnet and I broke it, like if I literally split this magnet right down the middle, in which I would have two magnets, then these two magnets that are a result of this split will have a north pole on one end and a south pole on the other end. And this magnet right here will have a north pole on this end and a south pole on this end. Okay, so splitting up magnets just creates more and more magnets with both a north pole and a south pole. Guys, it is not possible to have monopoles for magnets in nature. The same thing here. If I take these two magnets here, so let's say I take this magnet here and I split it along the middle. So I split it here. Once more, if I take this magnet and if I split it, I'm not going to just have one end that's north and one end that's south. Then I'm going to produce this. I'm going to produce two magnets that have a north pole and a south pole, and this magnet has a north pole and a south pole. The same thing if I take this magnet here, if I split it. If I take this magnet and I split it in two, then the resultant magnets are going to have a north pole and a south pole. And guys, I can take these two magnets here and I can keep splitting them. The same thing for these two magnets here, I can split them. Same thing. The magnets that are produced are going to have a north pole and a south pole. Guys, I can take magnets and I can cut them up an infinite number of times. Each tiny magnet that is produced will have a north pole and a south pole. So this is something I need for you guys to keep in mind. It is not possible to have monopoles for magnets in nature. Okay. So that's the important difference between magnetic charges and electric charges. You know, like for electric charges, it's possible to have a positive charge separated from a negative charge. So that's possible. So you can have monopoles with electric charges. However, that is not true for magnetic charges. All magnetic charges in nature have a north pole and a south pole. Okay. So that's just an important fact I need for you guys to keep in mind. So everybody got that? Okay. So I'm gonna sum up what I say today. What I said today. So just like electric charges, in which opposite charges attract and like charges repel, a similar thing happens with magnetic charges. Opposite poles attract, like poles repel. So north pole is attracted to north pole, and south pole is attracted to north. I'm sorry, north pole is repelled by north pole. South pole is repelled by another south pole, and of course, a north pole is attracted to a south pole. Okay, so in that way, magnetic charges are similar to electric charges. One way in which magnetic charges are different from electric charges is that it is not possible to have monopole magnets in nature. All magnets have a north end and a south end. That is always true. Any questions? Okay, guys, any questions on magnetic fields and magnetic forces? Okay, before I let you guys go, I just want to remind you all that whenever you're working on that test that is in Schoology, I want to remind you guys of Ohm's law. Whenever you're calculating electric current is equal to voltage divided by resistance, right? So I stands for current. I stands for electric current. We know the unit for current is amps. Okay. V stands for voltage. And the unit for voltage is just volts. And then R stands for resistance. And the unit for resistance is the ohm. Okay. So, guys, you're definitely going to need this equation whenever you're working on that test that I have in Schoology. Okay. One more thing that I want to discuss. Whenever you guys are working on that test, remember that, guys, whenever we draw circuits, so like let's say I have a circuit here, and obviously like I have a light bulb, connected to this circuit. I can have a light bulb or some sort of resistor. Remember, guys, whenever you're drawing a circuit. Whenever you're drawing a circuit, all circuits are connected to some form of battery or energy source. I want you guys to remember that the longer line represents the positive end, and the shorter line represents the negative end. So this is how we represent a battery in a schematic diagram of a circuit. Okay, so just something to keep in mind whenever you guys are working on that test. Okay. All right, guys. So if you log in to Eduphoria, you're going to see an assignment that says 6 weeks tests. Guys, it's probably one of the easiest 6 weeks tests you're going to have all year. There's only 15 questions, 15 multiple choice questions. You guys must have that test done before Friday. If you get it submitted after Friday, it is considered to be late. So be sure you have that 6 weeks test done before Friday. It's already opened up in Schoology, so you guys can get started on that right now if you want to. All right, are there any questions for me? All right, if there are no questions for me, you guys are free to go. Please fill out the attendance form if you have not done so. I'll see you guys next week, everyone. Bye, guys.